Good morning, students. In our last class from the chapter triangle, from the exercise 6.3, we have done some questions, isn't it? So we have to continue this exercise, and the next question is, if you see this question, the next question is here given, question number 7. If you see the figure here already mentioned, and here given altitude AD and CE of triangle ABC intersect each other at the point P, such that here what we need to prove, so that first one is given triangle AEP similar to CDP, second one is given ABD similar to CBE, and the third one is given AEP similar to ADB, and the last one is given PDC similar to BEC. So these four triangles here we have to prove similar. So one by one we have to do. Very simple question here. If you see, very simple question. The first one is here AEP and CDP. So that means if you see here now AEP, what you have to do when this type of questions are given to us, so just we have to identify the triangle here. So the first one is given AEP and CDP, isn't it? So now just we have to identify these two triangles from here. So if you see the diagram here, so AEP, that means this one is a triangle here, and the second one is which one? CDP, that means this one is a triangle. So what we need to prove? We need to prove these two triangles are similar. So the first one, if you see the first one, if we prove, so here just we have to write here in triangle AEP and triangle, and the second one you have to write triangle CDP. So just what we have to do, we have to draw these two diagrams separately. So that's why if we draw here AEP, so this one is AE, here this angle is 90 degree, then P. Is it clear? And another one is here, if you see the diagram is given, so here this one is D, it is 90 degree, here it is C, and this one is P. So these two triangles are given here. If you see, one is this one, another one is this one. So in this case, if you see, what we can say about these two angles? These two angles are vertically opposite angle. One angle is CPD, another one is APE, isn't it? So these two angles are what? Vertically opposite angles. So that's why easily we can say here APE and CPD. These two angles are what? Vertically opposite angles. And already mentioned it is perpendicular, so that means 90-90. So that means these two angles are what? 90 and 90. So I think all of you understood now what you have to do. One angle is this one, another angle is this one. If two angles, if we get equal, if we get equal, then which criteria we can apply? By angle similarity criterion, easily we can prove these two triangles are similar, isn't it? So now here what you have to write here, first of all we have to write this one AEP and CDP. So first of all we have to write here angle AEP is equal to angle CDP. So in bracket you have to write this one is 90 degree each. Is it clear? So here 90 degree, 90 degree. That means here AEP, another one is CDP. So these two angles are equal, here we get. And the next one is here what you have to write APE. So second one we have to write APE is equal to which angle? CPD. So we have to write here angle CPD. So this one you have to write here vertically opposite angles, VOA. Is it clear now here? First one is AEP, CDP, and second one is APE, and here CPD. So two angles are we get equal here. If two angles are equal, then easily we can apply here which criteria? By angle similarity criteria. So that's why we have to write by angle similarity criterion. By angle similarity criterion. So easily we can write these two triangles are similar. So that's why we have to write here triangle AEP is similar to triangle CDP. So this one is our first answer. Triangle AEP similar to CDP we need to prove in our first question. Is it clear? I think very easy and very simple question this one. So in this way easily we can solve this type of questions here. And the second one is now here, after completing this one, now the second one is given here, ABD and CBE, isn't it? So where is ABD? ABD and CBE. This one is we need. So now let's see the second one. How can we do? The same process. The same process we have to do here. So for this, now if we write down the second one here, if you see the second one, so here the second one is here, ABD and CBE. So second one, in triangle ABD and triangle CBE. So these two triangles we need to prove similar. Is it clear? So now here in this case, if you see ABD, this one, and second one is CBE. These two triangles are here. So separately, if you draw the diagram here, ABD, so that means ABD is this one. If you see, this angle is 90 degree, D, and here it is A, this one is B. Separately here we draw. And next one is CBE. CBE, that means this one. So CBE, so this one is E, here C, and this one is B. 90 degree, this one is 90 degree. So in this case, if you see here, one angle we get 90 degree, and the another one is, if you see here, angle B, ABD or EBC, or we can write CBE, whatever you write. ABD and CBE, both the angles are what here? Same. That means this angle is what here? Common. So angle B equal to angle B we can write, or you can write ABD equal to CBE, because it is common. So again, how many angles are we get equal here? Two angles. If two angles are equal, then which criteria we can apply? Angle similarity criteria. So that's why first of all you have to write here ADB. So angle ADB is equal with CEB. So that's why we have to write this one is angle CEB. So this one you have to write here 90 degree each. Is it clear? And in the same time here, second one we have to write ABD. So this one you have to write angle ABD is equal with CBE. Angle, this one you have to write here CBE, and this one in bracket we have to write common. I think all of you understood this one. So therefore by which criteria? Again by angle, you have to complete this. Therefore by angle similarity criterion, what we can write? ABD and CBE are similar. Therefore we have to write here ABD, triangle ABD similar to triangle CBE. Is it clear? ABD similar to CBE. I think all of you understood this one. One angle is common, another one is 90 degree. So in this way easily we can solve the second one. So second one is also proved here, and the third one is given AEP and ADB. So if you see here AEP and ADB, so these two we need to prove here in the third case. So now here, after completing this number 2, now third one we have to write here, and in the third case the triangles are considered, we have to consider triangle AEP. So AEP and triangle ADB. So that's how we have to write this one is triangle ADB. AEP and ADB we have to take, and these two triangle now we need to prove similar. So separately if you draw the diagram here AEP, that means this one is the diagram. So that's how we have to write this one is A, here it is P, E, P. E is what? 90 degree here. At the same time the second triangle is ADB. So that's why here we have to draw this one A, this one is D, here B. Angle D is what here? 90 degree. Is not it? So these two triangles are here we take, and now what we need to prove? These two are similar. Again you see one angle is same, 90 degree. Is not it? And now here one more angle. If you see in the both cases one angle is common. Which one? Angle A. isn't it? If you see here in the both triangles, this angle A is common, so here A is common. So again, which criteria we can apply here? By angle similarity criteria, again we can prove these two are similar. So that's why we have to write here angle AEP. So we have to write angle AEP is equal to ADB, angle ADB. And another one we have to write here E, or we can write here EAP, or we can write angle A equal to angle A also, you can write same thing. Is it clear? Angle A equals to angle A you can write. So here this one is 90 degree each. Is it clear? And this one we have to write here common, because both the angles are common here. Angle A equal to angle A simply. So by which criteria? By angle similarity criterion. You have to complete this. By angle similarity criterion, what we can say? These two triangles are similar. So that's why we have to write here triangle AEP is similar to triangle ADB. Is it clear? I think all of you understood this one, isn't it? Okay. Now the next one is here. The next one is given PDC and BEC. PDC. If you see here PDC and BEC, these two triangles we have to take now. So after completing this one, the third one, now the next one is here we have to take PDC. So the fourth one, in triangle. So we have to write here in triangle PDC and triangle BEC. So triangle BEC. So these two triangles are now we need to prove similar. So again we have to take the triangle here PDC. So if you see the diagram here PDC, so this one is P, here it is D 90 degree, and this one is C. Is it clear? And the next one is BEC. So if you see here the triangle, here it is B, this one is E, and here it is C. So angle is 90 degree. So in both cases, if you see here angle 90 degree, this one is equal, and one more angle is equal here. Which one? Angle C. If you see this angle C is common on both, so that means again which criteria we can apply here? Angle similarity criteria we can apply here. So that's why what you have to write here. First of all we write PDC angle, this one you have to write PDC is equal to, we have to write here BEC. So we have to write this one is angle BEC, and this one we have to write here 90 degree each. Is it clear? And the next one is C equal to C, so that's why you have to write here angle C is equal to angle C. This one we have to write here common. Is it clear? So these two angles are common here, and PDC and BEC are 90 degrees. Again, two angles are equal here. So therefore, which criteria have to apply? Therefore, by angle similarity criterion, we can say these two triangles are similar. So triangle PDC similar to triangle, this one is BEC. Is it clear? So in this way, easily we can prove this type of questions. So very simple question. Look like as very complicated question, but when we solve, you see here just two lines we have to write and then we get the answer. So in this way we can prove these four results. Is it clear? After question number 7, now if you see the next question, question number 8, and if you see the question is given here, the question number 8, and here the question is given in such a way that E is a point on the side AD produce of a parallelogram ABCD and BE intersects CD at F, as you see the question is given here, so that triangle ABE similar to CFB. So that means here first of all what you have to do, first of all if you see the question here, now in this question first of all we have to draw a parallelogram. So that's why first we draw a parallelogram ABCD. Is it clear? Listen carefully. So here first of all ABCD, a parallelogram we have to draw, and then what you have to do, we have to produce this AD line. We have to increase this line or produce this line AD up to this place, suppose. That's why here drawn here dotted line. That means that we have to produce this line. So if AD produce here, then up to E, here we produce. Is it clear? And now from this B, again we join this E. Is it clear? First of all we produce this AD up to E, and then from B again we join this E, and when we join this E with B, then this line BE intersect the CD line at one place, and which one we denoted by F here. Is it clear? Now in this case, what we need to prove here? We need to prove this triangle ABE. One triangle is this one, is not it? And another one is CFB, this one. So these two triangles are, we need to prove here, similar. Is it clear? So for these three criteria are there: angle, 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 side angle, side, and side, side, side. Out of these three, any one we have to apply here. Is it clear? So that's why first of all, if you see here, now one thing easily we can say here, since ABCD is a parallelogram, if ABCD is a parallelogram, then their opposite angles are what? Always equal. So easily we can find out here one angle, and which one is angle A is equal with angle C. As well, because it is a parallelogram, that's why their opposite angles are equal. First one. Now next one is, if you again you see here, since ABCD is a parallelogram, the property of parallelogram is what? Opposite sides are equal and parallel. So that means here AB is parallel to CD, is not it? As well as AD is also parallel to BC. If AD is parallel to BC, if we produce this line, that means the whole line AE is also parallel to BC. Easily we can say here, is not it? So if AE is parallel to BC, then if you see the diagram here, if AE is parallel to BC, then easily we can say BE is what? Transversal. In class 9 we get this type of conditions, is not it? So that means if AE and BC are parallel, then easily we can say BE is what? Transversal. If BE is transversal, then what we can say about these two angles? These two angles are alternate interior angles. You just rotate the copy, and then easily you can identify the diagram here. If you see BC is parallel to AE and BE is transversal, so easily we can say this angle and this angle, these two angles are what? Alternate interior angles. Is it clear? So if these two angles are alternate interior angles and opposite angles are equal, how many angles are we getting here equal? 2. So if two angles are equal by angle-angle similarity criterion, easily we can say these two triangles are similar. Isn't it? Very simple question. So just we have to construct the diagram properly and identify the angles here. So easily we can solve this type of questions. Is it clear? So now here directly we have to write here. First of all, we have to write which angle. Either you can write BAD or simply you can write angle A and angle C. So first of all, you have to write here in triangle ABE. We need to prove these two triangles, so that's why we write in triangle ABE and triangle CFB. So these two triangles. One triangle is this one. If you see ABE and another one is CFB. These two triangles. So if we take these two triangles, so now here easily we can write here angle A equals to angle C. So in bracket, what is the reason you have to write here? Opposite angles of a parallelogram ABCD. So here we have to write here opposite angles of a parallelogram. Opposite angles of a parallelogram, we have to write this one is ABCD. Also already we know this one, opposite angles of a parallelogram are always equal. So that's why we write this one. Is it clear? Now next one is you have to write here, since AE parallel to BC, we directly write here AE parallel BC and BE is transversal. Is it clear? Since AE parallel to BC, that means this AE parallel to BC and here BE is what? Transversal. So if BE is transversal, then we have to write here CBF, or simply we can write here CBE also, but no need to write E. Easily you can write CBF. That means we have to write here angle CBF is equal with which one? AEF, angle AEF we can write, or we can write here AEF or AEB also we can write. So it is more comfortable to write similar, so that's why you have to write here AEB. Understood or not? Whatever you write here CBF or CBE, meaning is same. Similarly AEF or AEB, meaning is same. So that's why simply we write here CBF is equal with AEB, and in bracket you have to write this one is alternate interior angles. Is it clear? So if these two are alternate interior angles and this one is opposite angles of a parallelogram, now which criteria we can apply here? So therefore by angle similarity criterion, you have to complete this. Therefore by angle similarity criterion, easily we can say triangle ABE is similar to triangle CFB. Is it clear? So very simple question here. So in this we can prove this one. I think all of you understood this one. So today we have complete 2 questions here, isn't it? And now in this we have to complete the whole exercise one by one question we have to do. In our next class we have to again complete 2 or 3 questions. So first of all you have to practice these 2 questions properly, especially this question is very important examination point of view. So practice properly, and if any doubts still remain then you can ask me. Is it clear? Okay, thank you.